Hey, got a minute? Let's talk about bees. Let's read a book. We're also talking about feedback loops. Heterogeneity, or when things are different, causes different behaviors in large groups that the average of the group doesn't actually illuminate. It causes feedback loops that are positive or negative, which cause quick cascades. Let's talk about how bees show us this. So, beehives need to maintain an average temperature, and it's actually a pretty narrow range. When the hive gets too cold, bees get together and buzz and make it warm. When it gets hot, they spread out and they buzz to make it cool, to create airflow. Bees that all get cold at the same time cause wild swings in a hive's temperature because they all start doing the same motion at the same time. However, bees with a lot of diversity, because they act differently, create more stable temperatures. If a few bees begin slowly raising the temperature, it's much more likely to stay within the range than if a whole bunch of bees very suddenly start trying to raise the temperature all at once. This is why diversity matters in complex adaptive systems. However, there are situations when this is worse. The key element is that we need to view the hive as a complex adaptive system. The individual bees don't cancel one another out. They are a part of the feedback cycle of the system. Bees fight because they sense the fight pheromones of other bees. If each bee has a different threat threshold, as in, if I see 3 other bees fighting, I'm going to go fight, versus another bee that needs to see 5, and some bees that only need to see 1 other bee fight, versus a homogeneous hive where every bee needs to see the same number of bees fighting in order to start fighting. Here's the problem with the heterogeneous hive of threat response. If one bee begins fighting, then all R1 bees will begin fighting, and then that will cause all R2 and above bees to also begin fighting in stages. This is where average behavior is misleading. If the bee threat model for each individual heterogeneous bee is spread evenly across the possible number of bees, we find that the whole hive is on a hair trigger. A homogeneous hive won't go into a full-scale attack until there is a major threat. In the temperature system, heterogeneity leads to stability because we're trying to keep a number between a range. In the defense system, the heterogeneity leads to instability because of the cascade effect. Feedback is one of the key features of complex adaptive systems. There are situations in which heterogeneity is important and situations in which homogeneity is important. Okay, now you know feedback loops in complex adaptive systems, or at least you know about feedback loops in complex adaptive systems. Stay tuned, tomorrow we'll talk about democracy.